Okay, so this is part 3 of Math 0314, lesson 1.1. I promise this will be the last one for this section. Also keep in mind that the first section is pretty intense. The other ones are not going to be nearly as long, so don't feel like this is going to be for every section. Okay, so what do we do here? Hopefully you've had a go at it. So what I would do is I would clean up the inside first. So I would distribute the negative x. And I'm going to get 3 braces x, negative x. I said braces, but really bracket. Plus 1, close, equals negative 2. Now, hopefully you were looking at that and you were like, no, Mr. Anderson, that has to be negative. And that is correct. Okay, so something interesting happens here. X minus x goes away, right? X minus x is 0. So I'm left with 3 times negative 1 equals negative 2, or negative 3 equals negative 2. This is strange, and that's okay. When we have a situation like this, we call this a contradiction. Okay? Basically, it's producing a result that isn't true, right? It's a contradiction. So there's nothing else I can do here, just say it's a contradiction. Okay? So anytime you get when the left and right don't make sense, they don't add up to each other, then you just say contradiction and move on. Okay. So have a go at this. Pause the video and try this real fast. And I'm going to assume that that's what you've done. And so let's see what happens here. So here if I distribute, I get 15 plus 5c plus 2 equals 2c plus, well, you know what? Why don't I just put them together? I can put these two together, right? So it was equal to 5c plus 17. If I clean this side up here, I can combine the 15 and the 2. So this is 5c plus 17 equals 5c plus 17. Huh. That is true, right? That is, I just got the left and the right to match up exactly. And when that happens, that means any value of c works. We call this the identity. Okay, so if you get the left and the right to match up exactly, you get what's called the identity. What that means is any value of c that you plug in will work. If you plug in 1, you'll get the right answer. Plug in 0, you'll get the right answer. Plug in pi, you'll get the right answer. Plug in negative 2.75, you'll get the right answer. Okay? Over on the contradiction case, if you plug in any value of x, it doesn't matter. You will always get it to say a contradiction. Okay? Let's try 25. So stop the video and try it real fast. And hopefully you've done that. How do we go about solving this? Well, we just need to put the numbers together. So we'll get 20 equals 4x. Divide through by 4. And x is 5. So this is a typical problem, and what we really say is that this is the conditional case. Okay, the conditional case is this statement here, 4x minus 3 equals 17, is true on the condition that x is 5. In all other cases, it is not true. So, what we're doing here is, if you recall from the previous class, is that 4x minus 3 equals 17 is what we call a statement. And a statement basically means it's either true or false. Okay? This statement is true on the condition that x equals 5. Back on 24, it is always true. No matter what you plug in, it will always be the case. And on 23, we get what's called a contradiction, and that means that it doesn't matter what you plug in, it's never true. That statement is never true. Okay? So, try 26. It probably will be one of the 3 scenarios, and we'll talk about it afterwards. So, I'm going to assume that you've given it a go, and let's tackle this together. So we're going to start off, again, I'm just going to distribute the 2 into both sides. So I get negative 10x minus 2 equals 2x. You know what? Why don't I put 2x and negative 12 together? So that'll give me, what's that going to give me? Negative 10x, watch the signs, plus 6. Okay? So we can see here both sides have 10x, so those will go away and we'll get negative 2 equals 6. So what do we call this? Hopefully you said contradiction. let's see the next one. So stop the video, try it on your own. Once you've done that, follow along. Okay, so we'll distribute the 2 into both of these. I'll also distribute the 6. So 6x minus 2 equals 6x plus 6 minus 8. 6 minus 8 is negative 2, so 6x minus 2 equals 6x minus 2. And the left and the right match up. No, you can keep going, right? I could add 2 and I'll get 6x equals 6x. I could divide through by 6 and you'll get x equals x, or I could subtract x, I could get 0 equals 0. There's a lot of different ways, but once you get the left and the right to match up, whatever you do, they'll always match up. And we say whenever this happens, we get what's called identity. Okay? And 28, pause the video, have a go at it. I'm assuming that you've had a go at it, and so what are we going to do here? 4x minus x is going to give me 3x plus 1 equals 6x minus 2. I'll consolidate my x's. Get 1 equals 3x minus 2. I'll put my 2 to the other side. 3 equals 3x. And divide through by 3. And x is 1. Okay? This is what we call conditional. It is true on the condition that x is 1. And that's it. So, hopefully that makes sense. We are done with 1.1 finally. And I hope this all makes sense. Feel free to rewatch these videos, and hopefully this will help you get through the homework. I'll see you in the next video.